Hello, today we're going to be looking at the topic of limiting reactants. In order to solve these problems, we need to first know what they are. So limiting reactants, that is in a chemical equation and in a chemical reaction, the reactant that's going to run out first. So sometimes you have some excess material and sometimes you have some leftover material. That is not the limiting reactant. The limiting reactant is the one that gets used up first. So if we look at this equation here of how we can make some table salt using sodium and some chlorine gas, we can look at how much of our sodium and how much of our chlorine gas are we going to need in order to use one of the two up or use all of it up as we make our sodium chloride. So if we compare this to just making s'mores. We'll think summer here. And if you roast a marshmallow and you want 2 graham crackers, 1 marshmallow, and then one of the chunks of chocolate in there to make your s'more, you want to know how much of each of the reactants you need to make your final product. So here we have a reminder of our equation. And if these are the amounts of marshmallows, the amounts of the graham crackers, and the amounts of the chocolate pieces that we have, how many s'mores would we be able to make? So as you compare these down here, hopefully you're finding that we will only be able to make 2 s'mores. And if we think about what is the limiting reactant, which of these 3 are we going to run out of first? That answer is the graham crackers, because we'll have 2 graham crackers for each sandwich that gets used, and we'll still have extra chocolate and we'll still have extra marshmallows that are left over. So we're going to use that same kind of concept in chemistry as we look at different reactions and equations. Now there's 3 main steps that I like to narrow limiting reactant problems down to. The first one is you always want to start with a balanced equation. So if it is not already balanced for you, you want to make sure we do that. Now we're going to use an example here of sodium and iron oxide. So now with my second step, I'm going to have for each reactant to calculate the amount of product formed. So I'm going to pick one of the products and then use it for both of the reactants. You're going to compare the amount of products that each reactant will form, and then the reactant that has the least amount of product that it makes, that one will be your limiting reactant. So let's go ahead and do that with this particular example and see what we come up with. Typically, you are going to be given a certain amount of reactant to start with. In this case, we're not given any amount, so I'm going to just choose an amount to start with. And we're going to just say we're starting with 100 grams of each of the reactants. So if I have my 100 grams of sodium, in order to figure out how much of the product I'm going to make, I need to convert it to moles and then to the moles of our product. So if I'm using my periodic table and all my stoichiometry that I've learned, I'm going to cross out my grams of sodium here with its molar mass. And then with the mole ratio that I have according to this equation, and remember, we're going to go to the sodium oxide. So I can cross out all these units here. And then I would do the calculations for it, and I would get a total of 2.17 moles of Na2NO. And that's if I would completely use all 100 grams of my sodium. That's how much of the product I would get. Now I don't have to go to grams of the product because I can stop at moles and still compare that. So I'm going to also use 100 grams in this example with our iron oxide. And once again, figuring out the molar mass from the periodic table. So I can cross out all my units. It's important to keep those labels there so I know what product and what reactant I'm working with. And then lastly, we'll get our mole ratio, and I'm going to go to the same product. Okay, so these units are crossed out as well. And then the final product here is going to be 1.88 moles of our Na2 and our oxide. So when I solved for this, I went to moles of the same product. So these two amounts are going to be comparable. Now the last step that we said is that you need to go ahead and compare our two answers. So when I look at a comparison between how much product the sodium can make and how much product the iron oxide can make, I'm noticing that the iron oxide makes less of the product. Therefore, my limiting reactant in this particular equation is going to be my iron oxide. So you want to go back to what is the reactant that is limiting. Okay. Now let's try an example here where we would be making water from our hydrogen and our oxygen, and it gives us a set amount of what oxygen and what hydrogen to start with. So we're going to go through the same three-step process to see once what the limiting reactant would be. We already have our balanced equation, so we don't need to worry about that. And so our second step is to solve for how much each of our reactants will make of the product. In the problem, it says that we have 1.22 grams of oxygen, and that's going to react with 1.05 grams of hydrogen to produce the water. So we have to pay attention to those numbers here. So we got 1.22 grams of oxygen. So I'm going to use my stoichiometry in order to cross out my units and solve for how many moles of water the oxygen will make. So then we use our mole ratio here. And this is going to make 0.076 moles of water. Okay, that's how much the 1.22 grams of oxygen will make. So now we're going to do the same thing with the amount of hydrogen we have. So we're starting with our other reactant, and this one has 1.05 grams of our hydrogen. Now it has a different molar mass than what the oxygen had. So you want to make sure you're going back to the periodic table to check your numbers. And then when you get to this next step here of your mole ratio, you want to once again double check that you're using the correct elements from the equation. And I'm going to go to the same units here and the same product. So I'm going to go just to moles of water so I can save myself one step there at the end. If the question would ever ask you how many grams of the product you would make, then you can do that last step of our stoichiometry. So this is how many moles of water the 1.05 grams would make. So my last step now is to look at between these two, which one is going to produce less water? And the answer to that is our oxygen is going to produce less water. Therefore, my limiting reactant is going to be the oxygen. Even though I started with more initially of the oxygen, it still is going to run out first in this particular reaction. We have one more problem here to go through. So why don't you go ahead and pause the video and give this one a try on your own, and then you can come back to check your answer. So after you did your work, hopefully you have the same answer of the silver nitrate being the limiting reactant. You'll notice I went to the sodium nitrate as my product, but if you did the work to the silver chloride, you would get the same answer. So either one is fine. That concludes this video on limiting reactants. Hopefully you got some good examples and a better understanding of what we're looking at. Have a great day.